Hi everyone, and welcome to our online fest. My name is Robert, and my talk today is focused on a new project that we are working on within the foundation, and that is called the MariaDB Jupyter kernel. A bit about Project Jupyter. Project Jupyter is an aggregation of tools which are built on top of IPython, the interactive Python interpreter. Everything under the Jupyter umbrella is open source. Everything is licensed under BSD3. And let me tell you something. This is a very popular project, and it is also extremely cool. It has the capability to change a lot how we currently teach people in school, how we currently train employees, and it can also bring a huge chunk of transparency into the scientific research practices. The Jupyter products are designed to be quite extensible, and the good indicator of this is that there are, at the time this video was filmed, around 144 open source kernels for Jupyter Notebook, and these are developed by the community. Yeah, you actually heard that right. That is 144 programming languages and other technologies that notebooks can speak fluently. The most popular product of Project Jupyter is the notebook. It is a quite complex JSON document which contains code, results of execution, images, and other media. The notebook is the building block for every Jupyter product. Everything else is built on top of this concept. The capital N notebook is a client-server web application. This app knows how to render the notebook documents. It's the editor where you can write your code, execute it, and get the results instantly. The next generation of this Jupyter application is called Jupyter Lab, a more complex interface for notebooks, but still a single user application. The most complex one is called Jupyter Hub, a multi-user application with many authentication methods, and that one can be deployed pretty much anywhere. And it can also serve very large crowd of participants. An honorable mention goes to the mybinder.org project, which serves the exact purpose of transparency I was speaking about earlier. It can take a GitHub repository full of notebooks and turn it into a live web application so that other people can reproduce your results with just one click. The Jupyter products are used, as far as I'm aware, mostly to teach university classes, online courses. It is also used they are also used in employees training programs, but they are also used massively in data science applications. I've used them myself quite a lot during my university classes a while ago. Anyways, due to their application in data science, where problems are run against massive sets of data, and due to the effectiveness of MariaDB in dealing with data, I have the feeling that these technologies should become very close friends. What is a kernel? A kernel is a program and also a process within a Jupyter Notebook server, and this one is capable of understanding and executing the code that you just wrote in your notebook. Your Jupyter Notebook web page sends the data to the notebook server, which then forwards it to the kernel and transfer back the results of the execution into your browser. And that's pretty much what it does. To speak about our motivation for this project, not so long ago, I ran an experiment in which I computed various metrics and charts for our community contributions for the MariaDB server repository. I used Jupyter notebooks, and because of this, these statistics are easily reproducible every year whenever we need them or we want to compute them. And this helped us understand a lot what we need to do to be a better open source project. Kai, our CEO, is also a big fan of Python and notebooks and uses them in a lot of scenarios, such as displaying charts for his running activities and for building kayaking maps that he plans to follow during vacation. In any case, these past experiences converge into the idea of a MariaDB Jupyter kernel, and we plan to build it in the Jupyter spirit. That is extremely easy to use and extend, have it open source, and also be good looking. And so we started. After some design meetings, a lot of research, and the sprint of coding, we managed to create a working prototype. Let's have a quick look at it. I'll open a terminal window first. Let me just make it visible. Okay. So I already have a MariaDB server running and also MariaDB installed, but you'll also need to make it work. You'll also need to have JupyterLab installed. So let me quickly connect to the server and try to see the number of clients connected. So I just run the client. And I type show global status like threads connected. And as you can see, there is only one client connected. It's actually this one. So let's close the client and start JupyterLab. Just a second. A new browser tab was opened. Let me turn off the terminal first. Yeah. So a new browser tab was opened. In the main window here, you can see a list of kernels that you can choose from under the Notebooks tab. I have a Python kernel here. Some C++ kernels because I installed a custom C++ kernel some time ago, and also on the right there is a MariaDB kernel. Let's click on the last one. So a new notebook was started, and this one is actually using the MariaDB kernel. Let's open the terminal again and see if the number of connected clients changed. Let me make it visible first. Okay, hope it works. Okay, let me split the window, connect again, client MariaDB, and run the command again. Should have it in history, yep. Okay, so as you can see, now we have two clients connected. This means the MariaDB kernel actually connected to the server successfully. Good. Let me hide that again and go back to the notebook. Hidden. Yep. So as you can see, the user interface is actually good looking. We can choose, for instance, to create another notebook in a separate tab, and let's do that. Let's create a new notebook, but this time let's have a Python one. So we switch back, we hit File, New Notebook, and the JupyterLab prompted you with a menu, a drop-down list, where you can actually see the list of kernels you saw earlier on the main page. We have the Python, the C++ ones, and MariaDB. Let's choose Python. And now we have a new notebook which is running the IPython kernel. So let's quickly test it. Let's do some dummy prints. Print 3, and if I execute the cell, I get the result. And let's try a small experiment where we try to chart something. So let's do this from matplotlib import pyplot SPLT, and then create a small array 1, 2, 3, 4, and do plt.plot of x, and if I execute the cell, I get a new chart. It's actually very easy. It's cool that you can do something like this with just a minimum amount of lines of code. That's actually very cool. So in MariaDB we can do pretty much the same thing using SQL. So switching back, I can write the simplest query possible, select one, I hit the result, I get the result here. But let's also try to write a query that returns a bit more complicated result set. So let's select star from mysql.db, and as you can see, the kernel return a result set in a nice table which is scrollable. You can walk over the lines, they are highlighted, columns are highlighted. That's actually very cool. So you can also, of course, do pretty much anything a modern editor does. You can go back and change one of the cells and re-execute it. Let's actually just do that. So you can go back here to select 2. Now we have the new results. The prompt moved to the new cell. I can hit again Shift Enter and results are re-evaluated. So that's cool. You can also save the notebook and share it with someone else. And a nice tip for this is that a while ago GitHub implemented native support for rendering Jupyter notebooks. So you can just push your notebook file into a GitHub repository, and that's it. Everyone can see the notebook as it actually appears in GitHub. So that's actually very cool. Another cool feature here is that you can change the type of a cell in the notebook. So you can move it from code to Markdown, and this is really useful for creating nicely documented notebooks. So let's do that. So I have the new cell here. I change the code to Markdown, and if I type using the Markdown syntax, we've just ran a query using the MariaDB kernel, and I execute it, I get a line. Oh, I have a typo actually. So I get a line that is looking like Markdown, and that's actually very cool. So in the near future, the MariaDB kernel will support a set of Magics commands. It doesn't currently support at the time this video was filmed, but I'm pretty sure by the time it will be streamed, the features will be there. So in any case, we will provide a set of Magics commands for integrating your SQL with libraries such as Matplotlib, and also with other Python kernels. So let's do some fictive examples. So let's say you have a query like select 1, 2, 3, 4, 1, 2, 3, 4, which returns a data set similar to the one we used in the Python kernel. And with the line magic command, if you type line and execute the cell, you would get a nice chart, pretty much the same like you got it in the Python notebook. Another thing, we plan to implement df magic commands, which is looking like this, and you'll be able to write df and something like SQL data frame and execute the magic command, and this one basically takes the result of the last query and exports the data set in a nice CSV format file, which you can easily import into the Python notebook. And you can do it with something like pandas. Actually assign it to something. df equals pandas read CSV, and have something like data frame.sql, which is the name of the one we created in the MariaDB kernel. So executing this will just import your data that you had in the MariaDB server, and you can continue doing your Python magic from here, which is awesome. So yeah, let's move on. Sorry, let's close this tab, leave. Okay, so as I kept speaking about magic commands, let's see a bit what these features actually mean. So Magics commands originated in IPython, and they are basically some shortcuts that you can use to make your life easier. The Jupyter kernels are entirely responsible for implementing their own magic commands. Unfortunately, there is no IPython magics that are inherited for free. There are two types of magic commands as they were originally defined. You can have line magics, which are pretty much independent. They do their function on their own without needing any extra input, except for the arguments passed on the same line with the magic command. And you can also have cell magics, like the bash one you can see here in the slide, which takes as argument the entire code from the cell. So more exactly, in this example, the bash magic lets you write bash script within the cell, and when you execute it, the bash code is executed using the bash process, and that's very nice. And as I said earlier, they are designed to make your life easier. They are mostly their main purpose is to access the language powers faster. But they can also change the behavior of the kernel, or they can help you create bridges between multiple kernels for different technologies. And the cool side effect of these magics is that they are pretty independent mechanisms, or at least we designed them this way. So this means everyone can contribute their own magic to a kernel without too much effort or interference with other magics or functionalities of the kernel. Oh, that's a nice side effect. As for the MariaDB kernel, we plan for the first release at least a set of matplotlib magic commands and a magic for helping you bridge the MariaDB kernel with Python notebooks. But we also have a lot of interesting ideas, like switching between client connections on the fly, or even running small Python scripts directly from your MariaDB kernel. The kernel is written in Python, so that should be possible, right? I would love to hear some of your ideas too. Help us make this kernel as rich as possible, even with ideas, so it gets to help more people too. So if you love this idea so far and you'd like to play around with it, it is pretty simple to get started. You need to have MariaDB installed locally, and also you need JupyterLab. Currently, you need to install the kernel by cloning the repo and by running pip install locally. Unfortunately, at the time this video is filmed, packaging for Conda and PyPy isn't ready yet, but we are on our way there very fast. The complete instructions for installation are on the main page of the repository. Please take a look if you'd like. And I would love to dive with you a bit deeper into how the kernel works and fits inside the Jupyter Notebook ecosystem. So, in the top part of the diagram, you have your browser with the JupyterLab or Notebook web application. So, when you write your code inside the notebook and you execute a cell, the web app sends a message to the server side of the notebook containing as payload the code you just wrote. And when the message hits the notebook server, it is pre-processed and immediately forwarded to the already spinning MariaDB kernel. Behind the scenes, the kernel implements a well-designed communication protocol, and a very well documented, by the way, a good job for Jupyter for doing this so well. Thanks a lot. And for a lot of the actions you perform in the web application, a similar message to the above is propagated to the kernel. Some examples might include code execution, autocomplete requests, stopping or restarting the kernel, and many more others. So when the kernel receives these messages, it reacts in some way. From this point on, it is the only entity responsible for what the user experiences when the reply gets back to the browser. For code messages, for instance, the MariaDB kernel parses the payload and determines which parts of it contain SQL code and which parts of it contain magic commands. To execute the SQL code, the kernel performs some preprocessing, connects to the MariaDB server running somewhere, sends the code for execution, and gets back the result. And it does so in the simplest possible way. It directly uses and controls the classical MariaDB command line client that you all know, and it uses it as a subprocess. And as you most probably know, the MariaDB client is capable of talking to servers anywhere. And it is very efficient at doing this. So the Jupyter kernel inherits this all for free. For executing magic commands, the kernel is on its own mostly. This means it needs to parse them, understand their meaning, given different parameters, execute them and package the results in a nice compatible format with the notebook protocol. But because the kernel itself is written in Python, it gets access to a lot of the perks of being a Python program, meaning it can easily talk to charting libraries like matplotlib. It can easily export data in a easy to process format by other Python notebooks. So it gets a lot of perks. And this is pretty cool. You can access data using MariaDB server speed and proven reliability from your favorite notebook interface, using the SQL language you are very familiar with. And you can just switch the tab to a Python notebook, import that data, and perform analytics on it with very few lines of code. That is very cool. This project is still in very early stages. I advise you not to use it yet for more than playing around and see what it's capable of. But I encourage you a lot to do play around with it. By doing so, you are directly helping us to make it better and useful for more people. Also, I would love to see if you can find other use cases for the magic commands. Feel free to just open a pull request for a new one that seems useful, or just let me know in an email or message or something, and I'll try to make that happen for you. As always, we are thankful to our sponsors who helped us get here. It's always a joy to see lots of effort put into the same goals. That's very nice. And that's pretty much it. I hope you enjoyed this small intro into the MariaDB Jupyter kernel. Thanks a lot for taking the time to watch this presentation, and have fun for the rest of the fest. See ya!